Hello everyone. Welcome to yet another session on Introduction to Monitoring Deployed Applications. Monitoring your deployed decentralized applications or DApps is crucial for ensuring everything runs smoothly. Imagine you have just launched your DApp you need to know if it's performing well, if users are experiencing issues, or if there are any security vulnerabilities. By setting up a proper monitoring system, you can catch problems early, analyze how your app is being used, and make improvements over time. This not only helps you maintain the app's functionality, but also keeps users happy and secure. We'll be looking at different tools and techniques that can help you monitor your DApp effectively. Moving on, we have why is it important to improve monitoring of smart contracts? Let's break it down into four key reasons. Ensuring application reliability, identifying and addressing issues quickly, enhancing user experience, and maintaining security values. Explaining the first one, your DApp needs to work consistently to gain users' trust. Monitoring helps you quickly spot any issues that could disrupt service so you can fix them before they affect your users. Second, monitoring gives you real-time alerts when something goes wrong. This allows you to act fast, figure out what's causing the problem, and resolve it quickly. The sooner you fix an issue, the less impact it has on users. A well-monitored DApp delivers a smooth experience. When transactions happen without delays and errors are avoided, users are more likely to continue using your apps. Security is a big concern in decentralized apps. Monitoring helps you detect any suspicious activities or vulnerabilities early, ensuring your app stays secure and compliant with regulations. Moving on, we have monitoring tools and overview. There are several tools available that can help you monitor your app effectively. Those are Etherscan, SaGraph, Dune Analytics, and Chainlink Keepers. Etherscan is a powerful blockchain explorer for Ethereum. It gives you detailed insights into transactions, contracts, and addresses on the blockchain. The graph is like a search engine for blockchain data. It allows you to create subgraphs that make querying and retrieving blockchain data more efficient. Dune Analytics can help you analyze and visualize blockchain data. It lets you create custom dashboards and queries, which can help you monitor user behavior, transaction patterns, and more. Chainlink Keepers are decentralized services that automate tasks on blockchain like triggering actions based on specific events. They help you keep your DApp running smoothly by handling repetitive tasks automatically. Moving on, we have using Ethereum Etherscan for monitoring. Etherscan is a powerful tool when it comes to monitoring your DApp. It's not just a blockchain explorer, it's a way to get detailed information about every transaction and contract interaction on the Ethereum. For example, you can track each transaction, see how much gas is used, and check its status. You can also monitor your smart contracts to view their code and analyze how they interact with other contracts. This is crucial for spotting vulnerabilities and ensuring your controls. Moving on, we have monitoring on Etherscan. Here's how you can monitor on Etherscan. Get an API key, install Axios, define contract, and execute monitoring tool. First, you need to create an API key from Etherscan's website. This will allow you to make requests to their API. Axios is a JavaScript library that helps you make HTTP requests which you need for interacting with Etherscan API. You need to specify the contract address that you want to monitor. Once you have your API key and contract address, you can write code to fetch and analyze the logs from your smart contract. This gives you added insights into how your DApp is performing on the Ethereum blockchain. The graph is yet another powerful tool for monitoring. It allows you to query blockchain data in real time. Think of it like a search engine that helps you pull out relevant information about transactions, contract events, and more. By using the graph, you can keep a close eye on your DApp performance, identify issues early, and understand how users are interacting with their application. There are four major steps to set up a subgraph. The first one is define the subgraph. The second is specify data sources. Third is creating mappings, and fourth is deploying the subgraph. This is done by creating a configuration file that specifies the structure, data sources, and mapping for your subgraph. The second step involves you to configure the file Ethereum contracts you want to monitor by specifying their addresses and APIs. The third step is mapping, transform the raw data from the blockchain into entities you have derived in your subgraph schema. Finally, for the fourth step, you use the graph CLI to publish your subgraph to the decentralized network. Once deployed, you will start indexing data and making it available to the graph API. Moving on, we have example of subgraph configuration. There are three steps involved: schema definition, configuration map, contract mapping, and event handling. In the schema definition, you define the data address in the API in the subgraph. Dot YAML file so that the graph knows which contracts to monitor. For event handling, finally, the mapping.ts file contains the code that determines how the subgraph will handle and process the events it observes from the contract, mapping them to the defined entries in schema. Writing mappings in the subgraph. In the graph, event handlers are key to monitoring your DApp's behavior. They process the events emitted by your smart contracts and map them to your subgraph schema. For example, if you are monitoring an ERC20 token, you write a mapping for the transfer event to track who is sending and receiving tokens and how many tokens are being transferred. The data can then be queried through the graph API. Moving on, we have unleashing the power of blockchain analytics with Dune. Dune Analytics is a powerful platform that allows you to analyze and visualize blockchain data. It's incredibly useful for uncovering insights into how your DApp is performing and understanding trends in the broader blockchain ecosystem. Moving on, crafting custom dashboards in Dune Analytics. With Dune, you can create custom dashboards tailored to your monitoring needs, defining data source, write SQL queries, and visualize insights. The first step is to connect to the Ethereum blockchain and specify the parameters for the data you want to access. The second is to use SQL to fetch the relevant data. Dune's flexibility allows you to tailor these queries to suit your monitoring needs. The third step involves Dune is what Dune offers: extensive visualization options, which means you can represent your data in ways that make it easy to understand and draw conclusions from. Moving on, we have automating smart contract functions with Chainlink keepers. Chainlink keepers are decentralized services that help automated tasks on the blockchain. For example, they can automatically trigger smart contract functions when certain conditions are met, such as initiating withdrawals or updating data. This automation reduces the need for manual intervention and ensures that your app runs reliably and efficiently. Moving on, we have a guide on implementing Chainlink keepers. Chainlink keepers can be implemented in three major steps: creating keeper contract, implementing check upkeep, and define perform upkeep. The first step is to start by creating a contract that inherits from the keeper compatibility interface. The second is to create a function that checks whether the upkeep needs to be performed. And the third one is to execute the required action when the check upkeep condition is met. Moving on. Here we have a sample Chainlink keeper contract. In this example contract, keeper example.sol, a counter variable, is incremented every minute. This key function includes check upkeep and perform upkeep, which won't work together to ensure that the best practices for monitoring decentralized applications. Clear monitoring objectives, combining monitoring tools and regular updates and review. Set specific goals for a monitoring like tracking performance issues, user engagement, or security. The second step involves use both on-chain and off-chain tools to get a complete picture of your DApp's behavior. The third is the most important, that is continuously review and update your monitoring setup to keep it effective as your DApp evolves. Moving on, we have real-world monitoring examples and lessons learned. In the world of decentralized finance, DeFi, monitoring is especially important. For example, DeFi apps often need to track liquidity, interest rates, and transaction volumes. One key lesson learned is the importance of real-time data and combining both on-chain and off-chain tools for a comprehensive monitoring strategy. Moving on, we have monitoring a DeFi application, a step-by-step guide. There are 3 steps: monitoring needs, leveraging the graph, and visualizing with Dune. Focus on key metrics like liquidity, interest rates, and transaction volume. Use the graph to create subgraphs that index relevant data from your smart contracts, especially for lending and borrowing activities. Create dashboards and Dune Analytics to visualize the data from the graph, providing clear insights into your DeFi's app performance. Moving on, we have integrating real-time alerts and notifications. Real-time alerts are crucial for monitoring your DApp. You can integrate Slack to receive custom notifications for critical contract events, or use small notifications for a simpler setup. This ensures your team is always informed and ready to act quickly if something goes wrong. Here is an example on using Slack notifications for smart contract events. These involve 3 steps: the Slack API setup, the smart contract event hook, and the serverless function integrations. You set up a Slack app and configure it to receive messages from your DApp. The second involves modifying your smart contract to emit an event whenever critical action occurs. And the third one is using a serverless function like AWS Lambda to listen for these events and send notifications to your Slack channel. Thank you for this particular session, and I hope you have a great day.